So in the second part, we talk about surface wind patterns, because that's what we're interested in. You know, if you want to book sea travel, you want to go to South America, you know, maybe on a sailing boat, you definitely want to know about surface wind patterns. And there is this structure that repeats every year so that we can actually describe the wind. It's not chaotic motion, so it has a specific structure, and the wind's patterns have names. And shown here the structure. Okay. It's shown here the general structure of surface winds. Okay, and again, this sketch shows you the Hadley cells and stuff like that. Okay, and the intertropical convergence zone. But you can describe the general surface wind circulations as shown here on the right side. Near the equator, there is a zone called the doldrums, which has little wind. Okay, it's a relatively wind-still zone. And then a little bit away from the equator, we have the trade winds, okay, which are easterly winds. And easterly means wind coming from the east. Okay. All right. And then at mid latitudes, we have westerlies. Okay, you have the westerlies. Westerly means wind that comes from the west. Okay. In the southern hemisphere, we also have westerlies, and they are known as the roaring 40s, which are situated near a latitude of 40 degrees. It's actually changing due to global warming, the location, you know, but anyway, so that's there. And then near the poles, we have easterlies again. So just say it again in terms of the different definition of the terms that we use. Westerly means coming from the west, and westward means going towards the west. And in terms of ocean currents, we use westward, eastward, because we're interested and we want to know the direction the current is drifting us into, and in terms of winds, we want to know where the wind is coming from. So it's really important to understand that fine difference in terms of the words that we use. What's also illustrated in this sketch, and this is the reason why I use this sketch, is you have these weather patterns. You know, you have strong so-called cyclones forming, called here a polar outbreak. Okay, there can be an outbreak of very cold air influencing the weather over northern Europe and North America. Okay. All right. So now looking at seasonal variations. So here are sketches of the typical surface winds, okay, for January, okay, which is northern hemisphere winter, southern hemisphere summer is on the top, or the opposite season at the bottom. Okay, and you can identify the key wind patterns. You can see the westerlies in the southern hemisphere, and so. And there's also indicated here where are the regions where you have a high pressure at the surface, using the capital H symbol. Okay, and also using the regions where you have the low pressure. Okay, here's low pressure. And the low pressure regions are associated with the warm air masses, the zones where you have tropical convection. So anyway, So what's the difference? I don't want to confuse you so much here, but what's the key here if you look at that? The key here is actually looking at the intertropical convergence zone. Just flip from one to the next and back and see, there is some variation in where the intertropical convergence zone is located, because you learned that there are these Hadley cells and the zones of rainfall. And if you now look at that thick blue line here, you know where the rainfall center is, where the rainfall is. And if you move up and down, you can actually see that there's a big shift of the location, and you can see it moves northward quite a distance and sits here in July over the Asian continent. And you can also see that there are surface winds that actually feed air that comes from the oceans and feeds the intertropical convergence zone, creating extreme rainfall over this continent. Okay, over the Asian continent. And this is what we call the monsoon. Okay, the strong seasonal variation of horizontal wind patterns and the associated rainfall. Okay. Whereas in January, if you look at the same region, you get actually winds that come from the continents and go towards the Indian Ocean. So there's no rainfall in that situation. That's fascinating, isn't it? Okay, so that's what we're talking about. And I just want to show you one more sketch which shows it a little bit without all the confusing errors. Is the seasonal shift of the intertropical convergence zone. Okay, so if you now see a map like this, you might think, so what? You know what's happening here, but you need to know the backstory, which includes the circulation cells and the regions where you got rainfall. And then it all makes sense if you see that here. Okay, that's the seasonal variation of the location. And this concludes now the second part of this lecture.